In this tutorial, we are going to see how to analyze 5-point or 7-point Likert scale surveys using exploratory factor analysis and confirmatory factor analysis on IBM, SPSS, and AMOS. So stay tuned till the end of the video. To start with, a 5-point Likert scale is coded from 1 strongly disagree, 2 disagree, 3 neutral, 4 agree, and 5 strongly agree. And the coding and this order is very important. If you don't know how to code, you can watch one of the videos shared in the description box below. So this is a 5-point Likert scale, and these ranges, when transformed into the mean score, they are as follows. So from 0.80 to 1.79, this corresponds to strongly disagree. From 1.60 to 2.59, this corresponds to disagree. From 2.60 to 3.39, this corresponds to neutral. And from 3.40 to 4.19, this corresponds to agree. And finally, from 4.20 to 5, this corresponds to strongly agree as the composite scores of Likert scale items or statements. The next type of scale is called 7-point Likert scale, and of course it should also be coded from 1 corresponding to the negative values like strongly disagree, 2 disagree, 3 somewhat disagree, 4 neutral, 5 somewhat agree, 6 agree, and 7 strongly agree, in such a way that the higher the mean score, the more agreement is expressed in the composite score. And the ranges of 7-point Likert scale, or the ranges, are as follows: from 1 to 1.85, this corresponds to strongly disagree. From 1.86 to 2.71, this corresponds to disagree. And from 2.71 to 3.56, this corresponds to somewhat disagree. And from 3.57 to 3.43, this corresponds to neutral. For somewhat agree, the range is from 4.43 to 5.28, and agree from 5.29 to 6.13, and finally strongly agree has a range of 6.14 to 7. So these are the ranges of 7-point Likert scale, and when using exploratory factor analysis or confirmatory factor analysis, it is recommended, according to Hare et al. 2019, that 7-point Likert scale should be used, and it should be coded this way, depending again on the content of the scale. That could be satisfaction, trust, engagement, whatever there is. The most important thing is that the lower codes correspond to the lower meanings or the negative statements, etc. Then we are going to run exploratory factor analysis and see how we can interpret it using EFA style. So this is the first table of factor loadings and communalities using the Obliman rotated 5-factor solution for 30 Likert scale items, and the n corresponds to the sample size of 250. By the way, for running exploratory factor analysis or confirmatory factor analysis, it is recommended in the literature that at least a sample of 200 respondents should be there. So apart from this rule of thumb, I think a lower sample may not be accepted in conducting confirmatory factor analysis or exploratory factor analysis. So researchers should be careful with that, especially those aiming at publications. Then we have the second table, which is about the eigenvalues, the percentage of the variance, the cumulative percentage for factors, etc., etc. So it is reported this way. And for confirmatory factor analysis, we have goodness of fit measures that are the chi-square that should be lower, so it should be below 0.3, and normally it should not be significant, but most of the time the p-value of the chi-square is significant, but still it is accepted according to the literature. Then we have the chi-square and degrees of freedom or ratio. So we have the value that is less than 3, equal 3, so these are indicative of a good fit. For comparative fit index or CFI, so values that are equal or greater than 0.95 are considered acceptable in the literature. For the Tucker-Lewis index or TLI, so values greater than or equal 0.0 or 0.95 are also acceptable. For the root mean square error of approximation or RMCA, so values should be equal to or less than 0.06. And standardized root mean square residual, so values should be equal to or less than 0.08. And for incremental fit index or IFI, values should be equal or greater than 0.95, and normal fit index values should be greater or equal to 0.95, and goodness of fit index GFI should be again equal or greater than 0.95. So as you can see, some measures are called what we call goodness of fit, others are badness of fit. So this means that the higher they are, the better, or the higher they are, the worse. So this is in brief the CFA and EFA. We are going to have an example to practice this. We have this data that consists of different items that are measured on a 7-point Likert scale, ranging from strongly disagree to, or this is just 5-point Likert scale, strongly disagree to 5 strongly agree. And we need to run exploratory factor analysis, then we need to run a confirmatory factor analysis on this data. So to do that, we need to start with exploratory factor analysis. We'll go to analyze, then dimension reduction, then factor, and I need to put all those items here in this box. Let me just increase it this way for you to see. So from item 1, IV1, to item this one, so DV, I need just to move them here to the variable box, and in the descriptives I can just check Kaiser-Meyer, Alkane, and Bartlett's test of sphericity, determinant, significance level, coefficients of anything like that, entire image. If I want to be more detailed, then click continue. For the extraction, I can choose this extraction. This is called maximum likelihood, which is a common extraction method, especially if the data has this assumption of normality, etc. And then for the display, I need to have the scree plot. This is the most required visualization, and the eigenvalue greater than 1 is the one that is chosen here by default. Click continue. For the rotation, I will choose Varimax rotation. Can also choose direct obliquement. It depends on the literature and the previous studies that use the same scale. And then click continue. For the scores, I need just to keep this as like by default, or I can save as variables if I want to create no factors, but let me not do this at the beginning, maybe till later. For the options, I can just use sort by size and suppress more coefficients that are below 0.3 or 30%, and click continue, and then click OK. So here is the output. So what concerns us is the Kaiser-Meyer Alkane test of sampling adequacy, which has a value that is 97%, 0.2, which is good. So any value that is greater than 0.5, 0.6 is considered good. And the sig value here should be 0.000, which should be statistically significant. So if they are like the Kaiser-Meyer Alkane measure of sampling adequacy has a value that is greater than 0.6 or 0.5, this is good. And if the value that is called sig value or the p value is below 0.05, this is statistically significant, and hence we can say that this data is suitable for exploratory factor analysis. So let's just move to the other tables that are necessary. The communalities can help you see what items you can just remove from the scale so that you can improve it. Suppose that I have some values that have a loading or initial communalities rather they are less than 0.5 or less than 0.3, I can just remove them from the data. So I can just go back here, factor analysis, and I can just remove, for example, let's say this item has a value that is less than 0.3. I can just take it out from the analysis this way. I don't remove it from the data, but I just remove it from the analysis, and I will rerun the analysis. This is how you can just edit for exploratory factor analysis based on the communalities. Next, we have the total variance explained. As you can see here, we have 5 factors or 5 composite scores or 5 constructs that explain a cumulative percent of 82% of the variance. And you see factor 1 has the highest loading. This means that factor 1 is important. We need to see the items that form factor 1, and we need to give it a title. And of course, we need to place importance on factor 1 because it is statistically more predominant compared to the other factors. And there is this depreciation curve that goes from the top to the bottom, as you can see via the eigenvalue plot. So you see here factor 1 is always predominant, and then there is this depreciation curve or curve that goes along with all those items. These are the items or the questions in our questionnaire. You see from 1 to 40, so we have 40 items, and the same here from 1 to 40, these are 40 items. Then we have chi-square, degrees of freedom, significance for goodness of fit. So it is significant. This is bad, but still, anyways, we can just go with it. Normally, it is always like that, most of the cases. Then we have the rotated factor matrix, but what concerns us is the this one. So let me just see. We have the rotated factor matrix, but we also have the factor transformation. So what I can do here is that I need just to go back for the extraction, check for the rotation. I see that we have Varimax. For the options, we suppress small coefficients less than 30. I can just increase this value to 50. And rerun the analysis. So here you could see now that those items are loading, but we have some cross loadings like this one. So this like IV, all IVs. Then we have M mediators. Then we have moderators, and then we have dependent variables. For example, this item is cross-loading with this. That could be an issue. And we have 5 factors, but here just 4 factors receive the loading. This means that we could just change the rotation method from the Varimax to the direct Oblimin or the Promax. Let's just try with the Promax. Click OK. So each method, by the way, assumes some distributions of the data and some, let's say, correlations among the constructs. You can see here the items here are grouped together. This one does not have any correspondence. I could just choose another method, which is rotation method, direct Oblimin. Click continue, click OK. So by the way, I'm just showing you this data because the data that you have in your survey could be the same. For example, this one is good. However, there are some loadings that are negative. You see them here. This means that those items need to be reverse coded because they are showing negative values. So for factor 4, again, is not showing anything, etc. So there is this problem of rotation. So we need to adjust this. We need to find the best rotation that suits the data, and that the rotation that provides the best, let's say, model we can consider it. So here we are just running different rounds of exploratory factor analysis, and we are making edits in terms of the settings of the analysis as well as the configuration of the variables by removing or adding some variables. Or sometimes we can also do configurations with regard to reverse coding some items. You see, like when we are doing exploratory factor analysis, we don't do it at once. There are multiple rounds that are run, and each round we just read the statistics, and based on that we can see what decisions we can make and what actions we can take next. So after we find the best model, suppose that we found that this one, let's say the first one that is called the maximum likelihood with the so-called Varimax rotation is providing us with the good, let's say, representation of the data. So I will just take this rotated factor matrix and I will just copy it, and I will open AMOS. So here AMOS is opening, so that I can run what we call confirmatory factor analysis, because CFA cannot be run on SPSS, so we can run it on AMOS. So I will just open this data. So go to File, Data File, and then File Name. And here is the data. I will just open it and click OK. So now I need to draw this model here, but I can draw it, let's say, automatically. Before that, I go to View, and then I can just see the interface properties, and I can set them to A1 or A4 landscape like this. And I can go to plugins. If I install the plugins, I will find them here. And there is a plugin that is called Pattern Matrix Model Builder. So I will just need to click it, and I will just paste the rotated matrix that I took from exploratory factor analysis from this one here. and then select it and create diagram. So here it has been created, but let's see where it has gone. So we redo it. I go to File to open the data, then Data File, and then find it. Or I can go also to, there is an option here that is about data. So we can just use it to import the data. So anyways, let's just go to File, and then Data Files, and then File Name, and EFA, CFA, Data, OK. I need to save this. CFA. And then I go to the plugins, then the pattern matrix builder. I will paste the rotated factor matrix or pattern that I got from SPSS on exploratory factor analysis and create diagram. And here it is, you see. So this is the model. Here I can just name those factors given their names, for example, DV, EV, or IV, etc., etc. So I can just name them or just keep them like that. This one you see here, it doesn't have any items corresponding to it, so I can just delete it by just clicking this option, and I can delete it. Then I can run the analysis. So to do that, I can just go to Analyze, then Calculate Estimates, or I can just calculate them from here. So there is more than one variable named IV8. So here there are some errors like IV8. IV8, where is this IV8? If I just rerun the analysis, it says there is more than one variable named IV8. So where is IV8? So we have this one. So this one could be cross-loading in different constructs. So I need to find it and just delete the repeated one. So IV24. So for example, IV4 is repeated. You see it? So I would just delete it. It's cross-loading. Then IV8, you see, it's also cross-loading. IV5. Or maybe they are different IVs because we have different independent variables, that's why. So let's just rerun the analysis. Again, IV7. So be careful with naming the items, because that could create a challenge. Then rerun the analysis. IV3. IV2. Normally you shouldn't have these errors. Just here because I didn't name the variables well, so I need to do that. DV again. So where is the DV? So here I have an error occurred while checking for missing data in the group number 1. No valid license for AMOS was found, 11.0. Suppose that I have encountered this issue. An error occurred while checking for missing data. What shall I do? I need simply to just click OK or just close it. And then I will need to save this output or this AMOS file. And I need to go back to it here, open it. My desktop or the folder where I saved it, and I will rerun the model and it will work. You see, it is as simple as this. Just AMOS just gives these errors like that sometimes. So here I have run the estimates. I can go to the estimate analysis properties to run more let's say detailed analysis. So if I just go to Analyze, then Calculate Estimates, I can start the calculation. You see. But there are also properties, analysis properties, where I can just choose what I want. So here, analysis properties, and I need to choose, for example, maximum likelihood. Then if depending on the discrepancy, I can choose generalized least squares, unweighted least squares, scale-free least squares, and asymptotically distribution-free. I can just keep this maximum likelihood. In case I have some missing values or missing data, I can click estimate means and intercepts. But since I don't have missing values, I don't need that. Here, for the purpose of computing fit measures with incomplete data, fit the saturated and independence models, fit the saturated model only, and fit neither model. I don't need to click anything here. I just keep it by default. And here in the output, I need to see what I want to have in the output. So I want to have modification fit indices or modification indices in case the fit is not good. Of course, it may not be good in the first place. So here I need to set this at 4 as a threshold. I can also choose other let's say parameters I want or other statistics I want to have in my outputs. Let's say I want to have standardized estimates, squared multiple correlations, and if I'm just running the path model or the structural model that contains mediators or rather moderators, I could just also choose indirect, direct, and total effects, especially for mediators. And here I can choose covariances of estimates, correlations of estimates, etc. So I will just keep these by default like that, and I click close, and then I will run the analysis, calculate estimates. And here you see we have this icon, which is the input. This one is the output. So I just need to click this, and here I will see the correlations among the variables or the constructs. The higher they are, etc. So that will just help us with regard to what we call to discriminant and convergent validity, and these are the loadings. And here I could see the unstandardized estimates and standardized estimates. So I need to have the standardized estimates. These are the ones reported for EPA, and you can see here the standardized estimates. Most of them have high correlation coefficients, more than 70%, which is positive. And these are the factor loadings that we saw on SPSS. You see, so these are simply the factor loadings that we got from here. These numbers, so these numbers are here. They are just visualized here. Those ones, and also the communalities. It could be also the communalities that we have, or the factor loadings, mostly for the factor loadings. If you just go back to the communalities, you can see them. These ones, for example, IV1, it has this 886, so it should just go back here, IV1. So here there's no IV. Let's see M1. M1 854. So if you just go back here, M1 854. So these are different from here because I just changed the variable. So if you just make some changes, that would also affect the loadings here. Then we have what we call the analysis properties. We did that. And then we have the output. So I just click view text here, and this is the output. You can see here that the degrees of freedom are 272, number of distinct parameters are 53, and number of distinct sample moments 325. And this is the chi-square, the degrees of freedom, and the probability level of the chi-square is significant. So since the chi-square, so the chi-square should be positive, it should not be negative, and it should not be equaling 0 or something. So for the model to be just identified or maybe over-identified, but not under-identified. Here we just go to model fit. You can see here those values that we explained on the PowerPoint. So this is the chi-square. It's just written as CMIN, and here it is higher, and the p-value of it is greater or is significant, and here this one is slightly above the threshold that we discussed of 3. So it should be either 3 or below 3. Here this one is not a good fit because the chi-square should be either 3 or below 3. And then the other models, like the other, let's say, model fit indices like GFI, AGFI, etc. So we talked about GFI, and here other, let's say, the TLI, the Tucker Lewis should be 0.95 and above. This is like goodness of fit measure. This one, there is another measure that we have, or threshold that we discussed on this GFI. So what is GFI? This one, it should be equal or greater than 95, as you can see. So here it's not. And the same for adjusted GFI, etc. The TLI again should be greater than 0.95 or equal to it. The CFI the same, etc. So you could just see all those. The RMCA, it should be below 0.06 or 8, and the p-close should not be significant. Anyways, so here this means that this model needs to be improved in terms of the goodness of fit. So here I go to modification indices, and I will see which items I need to covary so that the model fit will improve. So here I just need the one, like the first one. If I covary error 38 with error 40, that will improve the fit. So let me just go back to the model, and let's see what I can test or covary. 39 and 40. So I will just go here back to the analysis and click this arrow, and I will covary these like this way, you see. But I cannot covary items from different constructs, like this one from factor 4 and this one from factor 3. That's not recommended. I can just covary items within the same constructs, and I can rerun the analysis, calculate estimates again, and then I go back here and analysis properties or view text, and I can see what the model fit will be like. So here we have modification fit indices, and here you could see the chi-square and other values. So I will just keep covariant based on the model fit indices till I improve the model. So if it's not improved, then I need to keep doing that till I improve it. So for example, this one 38 and E40. So I will just need to do the same. 38 and E40. 38 and E40 like this, and I will rerun the model. So we have first round, second round. We will have again multiple rounds of fitting this model till it has good fit indices. As soon as we have good fit indices, we can move from the measurement model to the structural model. If I have some plugins that will help me see the model fit indices quickly, so I just go to plugins. And let's look for, so here we have validity, we have name parameters, model fit measures like this. So here it will take me to this page. You can see here, these are your model fit could improve based on the standardized residual covariances. We recommend removing DV5. You see, it gives you recommendation, and it shows you the model fit indices along with their thresholds. And you see, for example, CFI, it's 9 and it's terrible. This one is again reduced to 0.04, and the normal threshold is this one, and this is excellent. The RMCA, and this is 0.06 and it's terrible. You see, so this one is good, like not estimated. And these are the acceptable thresholds. You can see we have also other plugins like validity, etc. You can download all of these from the Gaskins plugins. HTMT, for example, this one is about model validity measures. We have construct validity, discriminant validity, and convergent validity in HTMT, heterotrait, monotrait ratio. Okay, so we have different, let's say, plugins that can help you with regard to testing the reliability, validity of your model. You can just download them and install them. There is a special way. I have a video that explains that, and they will help you with regard to different tests. Okay, so just I want to show you the last part. If I just go to view text here, we have the estimates. Here you could find the estimates with regression weights and the standardized regression weights, along with the intercepts and covariances and correlations, variances, matrices, residual covariances, standardized residual covariances, etc. So you will find all of them here, and they will help you with regard to the analysis. So you keep running different rounds of maybe removing some items, covarying others, etc., till those indices are a good fit, and here you will succeed in fitting your measurement model and moving to the structural model for hypothesis testing like moderation, mediation, etc. So this is in brief how we can run exploratory factor analysis and confirmatory factor analysis on SPSS and AMOS. If you have questions or remarks, do not hesitate to post them below. See you soon. Bye for now.